All right, so this is the explain it to me like I'm a 5-year-old version of the Amazon web server setup, right?
Sounds good to me.
All right, so the first thing we needed was
The first thing that we needed was a domain name, I
right.
think. So we went to freenom.com. Now, my question about that was, when we got the domain name, did we get an IP address with it?
Nope.
Do you always get the two in tandem?
Nope. You did not get an IP address, and you don't get one just by virtue of getting DNS service. So what you're signing up for is a registrar, and that's just the thing that lets you get a response to a lookup. For Freenom, it's for those freaky addresses, but for like anything like a .com or a .edu or whatever. So you are really just getting just the name there. And in fact, some El Cheapo registrars don't even give you DNS services as part of the bundle. Most of them bundle it in. Many of the like pay services bundle like the whole thing in.
So, like IP address and everything?
Maybe. So IP address needs to go to a server, right? So we build an Amazon EC2 instance to make a server. And this, like, you could do all this with a, oops, darn it. You could do all this with a, like a Raspberry Pi in your house. You know, it would have an IP address. It would be the server. What we're making in the cloud is a computer that you control that has an IP address that Amazon gives you, and you can make it do things. So how comfortable do you feel about DNS and domain names?
So, DNS is domain name service, right?
Mm-hmm. A system.
Domain name system. And what that does is it takes a look at a domain name like google.com, and then it translates that domain name into an IP address, so the actual numbers, right?
Yep.
And it does that by looking at by connecting to a DNS server.
Correct.
And that DNS server just has like a list of the domain names and the IP addresses.
Yeah, do you want the like a little more accurate? This is not explain it to me like a 5-year-old. You've got the explain it to me like I'm a 5-year-old.
Yeah, hook me up.
This is a pretty good link. This is a visual guide, illustrated guide to one of the vulnerabilities in DNS. But this does a pretty good job of breaking down. Those are the actual packets. That might be a little too in the weeds. Hang on, I bet you Professor G wouldn't mind if I borrowed some of her slides for this. Just because I happen to have been looking at her stuff not too long ago. Wrong ones. It's actually like the tricky thing about it is it's like this recursive thing. So every website begins with dot. If you work backwards from the .com. So my website was what? It was cybercommand.ml. And actually technically it's cybercommand.ml dot, although we dispense with the dot by convention. It's just easier. But the dot represents the root DNS servers on the planet. And there are like 13 of them out there. DNS root servers. And there's the ones that are, they're A through M. It's got to do with the way DNS was set up. And they go, they respond to all requests for dot requests, right? So you start with your, like, do your, like, IP config on your computer and see where you get your DNS. /all if you're Windows or if config. My wireless adapter gets its DNS from my router.
Did you say that I do that?
That's ipconfig space /ALL. It looks like this. And I have a bajillion network cards on my computer because of what I do, but that's the deal. And here, this is the official Purdue stuff, adapted from Dave Levin. Credit to Professor Christina Garman, who's my teacher in my last security. So this is the breakdown. You start out, you're the requesting host here. You ask your local name server, hey, I need to get to cybercommand.ml. And your local server says, I don't know where the hell that is. So it goes out to the root DNS server, the dot server. And it sends a response back to your local server that says basically, hey, I don't know where to find cybercommand.ml, but I know the guy who knows all the .mls, and sends you the glue records for that. And then it says, oh, well, here's the server for the in this case, edu, but in my case, .ml. And then your local name server goes, hey, .edu, do you know where to find, in this it's going to be Purdue, but it would be cybercommand.ml. And then it finds the authoritative server, and this is the one you set up, right? When you get mywebsite.com, you set up this authoritative DNS server, and it just kind of works its way down to it. And that gives the actual answer of how to get to whatever it is you're trying to get to.
All right.
So that's DNS in 5 minutes. And then this...
I'll go take my networking cert tomorrow.
Oh, well, good. You should be familiar with that if you hope to pass the Network Plus. Although I don't know. How much of that did they hit you with? So yeah, there you go. Holy cow, is this a Windows 7 computer?
Yep.
You hipster, you. Is this like an artisanal Windows 7 computer?
This is a computer that I bought like 8 years ago for $40, and it still runs phenomenally.
There you go. All right. Even if, at this point, maybe you should be running it sort of ironically. That's how I run DOS these days. I get a little mustache and tight jeans. All right, so you're clear on why we went to freenom.com?
To get a domain name.
There you go. And in the case of freenom.com, they also provide that DNS server for you, which is nice of them, but not necessarily required of them. So what?
We went to Amazon Web Services, right? And they offer Amazon Web Services offers a ton of stuff. I was looking through it.
Yeah, don't get overwhelmed in that sea of products that they offer. The one we're concerned with is EC2 and their Elastic IP service, and that's about it.
Yeah, I gave up like immediately.
Oh yeah.
So the end goal of this was to launch our own web server, right? And,
You got it.
Here with Amazon Web Services, we were launching an instance of our own web server.
Yep, you were launching a Linux computer that you could get an IP address for, and then you're going to make it into a web server.
Can you say that one more time?
Yep, so you were going to make a Linux server, a computer. Like I said, you could do this with a Raspberry Pi if you wanted to. It's just that that's not how it works these days. These days you run your servers in the cloud. So in the server, you get a Linux computer, and when we started, all you can do with that Linux computer is basically connect to it. So it's just a computer on the internet that has internet access. So mine is grcc web apps, and we use some security stuff to connect to it.
So then what did you say after that? So we made a Linux server that we were going to turn into a web server.
Yep, so you make this Linux server in the cloud because Amazon's nice and gives us $50 a piece to run web servers. And then by virtue of the rest of that install document you've got there, we go through the process of first launching an instance. So that's if you imagine that there's a guy at Amazon who, when he gets the request from you, goes back into the server room and turns on your server. You've got an imaginary idea of what's happening. It's a little more complicated than that, but that's enough to hang your hat on.
Yeah, that's fine. That's all I'm looking for right now.
All right, so the web server, or the Linux server turner-oner guy, sees the version of Linux you want to run, goes back and flips the on switch, and then gives you the inside of Amazon address and a short-term public address. All right, so you can connect to it on the internet. And so mine got IP adder, wrong Linux version. So mine got like 172.31.21.228. And it got some address on the inside of Amazon's network. And that next step there, where we want to get a permanent network address, is where we need to reach out to Amazon's Elastic IP service.
Before we go there, let me just make sure that I understand what a web server is.
You don't have one yet, so don't worry about it. You have a Linux server right now. You might want to say, we may turn it into a web server. We will turn it into a web server. Right now, you've made a Linux server, and that's it, period, full stop.
Can you explain the difference?
A Linux server is just a computer that runs Linux and is on the internet. A web server serves up web pages. So right now, before you go to those next steps where that says LAMP and such, if you go to that website, nothing happens. So right now, it's just a dumb box sitting on the internet, not doing nothing.
Let me clarify something.
Yeah.
So when you said we didn't make a web server, were you referring to just where we're at in this
process? Yes, I am.
Right now?
Right.
But at the end of this process, what I did do was I did make a web server when I finished it.
That is correct. When you get past that setup LAMP, you have installed the program called Apache. Apache is a web server program that runs on a Linux computer. When we have a web server programming running on a computer on the internet, then we call that computer a server as well, which is, the language is a little confusing because a server is, the hardware itself, but it is also the program that serves up the web pages.
Okay, when you said we didn't make a web server, I thought you were referring to the whole process.
Oh, no. We haven't made a web server yet at this part, this step in the process.
But a web server is a dedicated computer that just serves up content off a web page, right?
Yeah, it doesn't have to be dedicated, but generally is.
Okay. So right now all we've done is we've set up an Amazon instance, and then you said the next thing that we want to do is get a permanent IP address.
Correct. So right now, if you were to restart at this step in the process, before you use Amazon's Elastic service, if you restart that server, it'll get another DHCP address. And if you're taking your Network Plus test tomorrow, you might want to remember that that's the Dynamic Host Configuration Protocol, right? It gets an address from some server somewhere, and it'll change. So if you're setting up all this web server crap, and you get your DNS pointed to an address, and that address changes, you have to go back and set up all the DNS all over again. So you want to use this Elastic IP address service that lets you keep the same IP address over multiple restarts.
Sorry, could you repeat that? It cut out for like 15 seconds.
Okay. So starting with reboots. So right now, as it stands, once you launch the instance, you've got a DHCP address, right? A non-permanent address that will get assigned a new address the next time you restart the computer.
A DHCP address is non-permanent?
Generally speaking. They sometimes seem permanent because, like, Your cable modem probably gets the same address just about every time until the cable company changes something. But yes, they're not guaranteed to be the same every time you get one. And with Amazon, it tends to be the case every time that server reboots, it'll get a new address. So if you set up all the rest of the stuff we're going to do, you know, point your DNS to that address, you reboot the server.
And it would break as soon as that DHCP address changes.
Bingo. Yeah, you reboot the server and now your whole infrastructure's broken.
So why is it called an elastic IP address if it's permanent?
Amazon's marketing people. You also can grow those. So I believe like in that product is the ability to grow the like number of places that IP address gets resolved to, which is beyond the scope of this class. But for let me double check that. Amazon Elastic IP. What are the features here? Gets you a pool for dynamic cloud computing. You can mask the failure of an instance. Oh, that's another thing. You could potentially have multiple servers behind that single IP.
Oh, gotcha. Okay.
You can do all sorts of fanciness with it. But what we want to do mostly is make sure that that doesn't happen. When you reboot your server, you've still got the same address that you set up in DNS, because that's coming up, right?
Yeah.
Hi, Drew. We're talking. Do you mind if Drew hangs out with us here? He's got questions about this assignment too. So that next set of steps is basically how to remote access into a Linux computer. If you're ready to move on from Elastic IP.
Should I get out of here a minute?
No, man, he said you're cool.
You can hang out if you want to, and if you have any questions, feel free to chime in. I don't care.
Oh, cool, thanks.
We're doing Explain It Like I'm a 5-year-old for setting up that Linux server.
Okay.
All right, I'm good on the Elastic IP address part.
There you go. Then this is all the stuff you should have learned in your Mac class or your Linux class. To connect to that server in the cloud, we use SSH, the secure shell. You may not have ever used like the whole certificate deal where you have to get a public and private key and you log in using a username plus the private key using Putty to make that happen. And so the Putty setup, if you'll recall.
Wait, all right, hang on. Sorry, this is already going a little bit too fast.
Okay.
So I haven't taken a Linux class yet.
All right. You might consider it. It's the wave of the future.
And we're connecting to our Linux because that was the instance that we launched, right? We just started a Linux computer.
Right. So you've got a server out there in Amazon Web Services land, and it has the you know, you have a connection to it. That's where all your hacktivities will go on. So when you want to type commands to that server, you need to connect to it somehow. And WinSCP is WinSCP is one of the tools we use, but Putty is the way you can get to the command line on that computer. Like you got to the command line on Windows by typing, you know, CMD, or your copy of Windows is sold that you got to it by typing command. But does that work? Can you run?
Yeah, that's how I opened it. I typed command.
COMMAND?
Yeah.
Holy crap. Those were the days. But so like you connect to it instead of with a username and password, with a username and a private key for authentication.
So we connected to it using SSH.
Yep.
Can you talk about SSH a little bit?
It's just a secure shell, and that's literally what those letters stand for. And by using a key, a private key, it establishes a text connection from my computer to the server. So this is my connection to my AWS server, and I can run commands on it, and I can, most importantly for this setup, we can configure the web server, which is going to be our next task, right?
So wait, did you say you used Putty is Putty just a thing that sets up the private and the public key connection?
Nope. So there's a couple of pieces to Putty. The one we're looking at on my screen right now, the black box here, is the Putty SSH session. So this is the command line connection to the server. So that's one of the things you can do with Putty. The other thing you can do with Putty is convert the weird AWS keys into the keys that Putty and WinSCP want to use to connect to your server.
I can't see your screen because I'm. Do you care if I stop sharing?
If you look over my shoulder in the video there, you can see it. But it's just a black screen with some text on it. I don't care if you stop sharing either, though. I can share that too.
I couldn't full screen it until I stopped sharing, so you're just a thumbnail.
Like if you weren't running Windows 7, man. You need more monitors. All right. So that's Putty as a command line client, right? It's the program I can use to typey things into this server.
So Putty's the program you're using to connect to the Linux instance that we set up, and then you're typing commands to configure it, right?
Yep, amongst other things, you know, all the things. We also needed to use that Putty Gen program in order to make the keys work, basically.
All right, give me 2 seconds to write some stuff down.
Okay. Drew, is this helpful?
Yeah. I feel like it's understanding it a little better.
Cool.
Yeah, I've been working at this. I did basically all night last night. I'm pretty certain. Well, I mean, I know my problem is, getting the DNS service forwarded to my IP address.
Yeah, if that screenshot you sent me is any indicator, it looks like you put the IP address where you wanted to put the DNS name on that interface you got from GoDaddy. So if you pull that up, my guess would be if you replace your IP address with the name of the server and then put the IP address somewhere else, that might do it. But if you get that, if you pull up the VeriSign, the GoDaddy interface, we could check it out.
Okay. You want me to screen share?
I don't know. How's Isaac doing?
So I've got what I wanted typed out. Do you mind if we finish out this process?
Nope. Keep going. Keep going.
So you were talking about not WinSCP. We're using Putty Gen to set up the keys.
Mm-hmm.
Is Putty Gen specifically for setting up public and private keys?
It's lets you. Yes, it is. It will generate them, and it also lets you reformat the ones from Amazon, which is what we care about for this process. So lets us.
Why do we have to reformat them?
Because Amazon uses an old format, and Putty and WinSCP want a newer one.
Was that the thing that they gave us a condescending message about?
Yep.
With the file? Okay, cool.
Sure was. They're like, oh, you're using these old nasty keys. We can change them to the newer, better format.
So we use Putty Gen to generate the keys.
Well, Amazon generated the keys for us when we set it up. We downloaded them, and then we used Putty Gen to make them work. And really, that's all just a matter of formatting too. Like the guts of the keys are exactly the same, but it's just the way they're laid out.
So when we set up our Linux instance at Amazon, it came with public and private keys?
Yeah, you set that up as you were going through. When it built the server, it lets you download the keys. Or, optionally, you could have provided your own, but let's not go there.
Okay. So then Putty Gen reformatted Amazon's keys.
Yep.
And then the next step was LAMP and Phpmyadmin.
Yep. Do you know what LAMP stands for?
About to.
Apache.
Oh, look at Drew. Yeah, Linux, Apache, MariaDB, used to be MySQL, and PHP. You're not going to need to worry about those last two until the next class, but you'll do this exact same assignment, except you'll need to get a database working and PHP for your next server.
So what was the point of LAMP?
So you've got Linux, right? L, that much is working. You got an address, you've got a DNS, and then the A is Apache. and Apache is the web server that's going to serve up web pages to your customers when you make them a web app.
Is Apache a web server, or is it web server software, or is it both?
So you're tripping over the words again. A web server is both the software that gives web pages up, so the software that does the web service, and the device that's running that software on the internet. So those words are synonyms, and confusingly so. So in this instance, when we're building a LAMP server, we're building a Linux Apache, and then those other things we don't care about yet. So really all you're worried about is the la part of the LAMP stack. And this is called LAMP stack. It's like a very common way to serve up web applications.
So all we needed from LAMP for this assignment was to add Apache so that our web server can actually serve up content.
You got it.
Cool. What is Phpmyadmin?
Software we'll use later on, but it is the my part of MyAdmin is MySQL. PHP is the software, the programming language we use to, and it actually means personal homepage. That's how old it is. The software we use to write web apps on the server side. I'm thinking about redoing this class so we use a different, like a JavaScript-based thing, but that's not going to happen by winter. I got to find a good one that I like and learn it. But so the M part is MySQL. That's your, or Maria database. That's the database that will be the backend for your website. And then the P part of that is the PHP. The Phpmyadmin is an administrative interface for like sending SQL commands and looking at your database tables on your server. So it allows you to do remote database administration and test out like the commands that your PHP code sends to the database to like retrieve records and stuff.
PHP allows you to do remote database. What did you say?
Nope. Phpmyadmin, that whole thing, is a web application. And if you wanted to know what Phpmyadmin did, what would you type into the Google machine?
What does Phpmyadmin do?
Yeah, I wouldn't even go that far. I just type Phpmyadmin. And it'd bring you to the web page that would tell you Phpmyadmin is a free software tool written in PHP intended to handle the administration of a MySQL server over the web, which is a better definition than I was giving. But it's this software that makes administering these servers easier than if you were to do it, you know, by the, like there's a command line interface for MariaDB that you can type SQL commands into, but usually that's a bit much, and it doesn't give you the option to like look over the like Phpmyadmin will build SQL statements for you, so it means you don't have to be a master of SQL, even though it is kind of like recommended you're familiar with it before you do those classes.
I'm reminding you, I have a meeting.
Alexa wants you to know you have a meeting. And you're officially using up Drew's time at this point, Isaac.
Last question, real quick then.
Mm-hmm.
So the last step is certificate authentication, and we're doing this to encrypt it so that the communication is encrypted and then our website or our web server is considered secure. Can you just talk a little bit about that process?
Sure. So we use this thing called Let's Encrypt, which will give you a free certificate to encrypt the communication between the web server and the web client. So if you ever wanted to like have a communication where your web client talks to this website and like provides a password, or God forbid a credit card number or something, that communication would be encrypted. And so if Alice is the web server and Bob is the client, when Alice sends the request for the credit card over, Eve can't eavesdrop on that communication because it's encrypted.
And Let's Encrypt does that for free. It encrypts information between the web server and the client.
Well, Let's Encrypt gives you a certificate, and this little guy right here on websites is telling you that there is a certificate involved and a secure connection going on. So the certificate is just the same kind of concept as those public-private keys we set up, except this one's for the web server. So using this and your client, they can set up a secure communication and keep the traffic between the two encrypted. Otherwise, I can read every, otherwise someone between you and the server can read every single thing that gets typed into a web page and every single thing that comes back from the web server.
Can you repeat that part about the certificate?
Sure. So you get this thing that we're looking at on my screen here. This is the details of a certificate, and it explains. It has an encryption key that allows us, or it provides encryption between the user, the client, your web browser, and the web server. So it allows Apache to encrypt all of that traffic. So Apache, the server program running on the web server that's doing the communication, by virtue of having a certificate and being configured correctly, which Let's Encrypt did for you automatically, it sets up that communication so that it is an encrypted tunnel that can't be decrypted. And if you're really curious about it, we spent like 2 different lectures talking about that in our Security Plus class. And long story short, it just means somebody can't look at the traffic on your web server if it's set up correctly. And Let's Encrypt does it A, for free, and B, pretty much foolproof. The Let's Encrypt bot does all the heavy lifting for you. You have to edit one file. It used to be this whole onerous ordeal where you had to pay a company to prove who you were to them. It was a big mess, is what it was. But yeah, so read more about it.
All right, that was all I had.
Well, and like,
gives me a better understanding of what we did and why.
and seriously, if you're curious about all that stuff, each one of those is a rabbit hole you should go down. We'll cover, like, if you did you say you were doing Network Plus?
No, I was lying. It was just a joke.
Do you just do? Are you just looking to be a web developer, or sometimes we get students in this class who are just looking to be like graphic designers? Which I got a whole thing about that. Or is this like something you're seriously interested in pursuing?
This is a required class.
That's it. Period. Full stop. Don't ever have any interest in making a web application again.
I don't know. I don't have the clearest idea of what I want to do.
Yeah. I'm always curious why people wind up in this. Are you in the web design and database, or a web design and graphics program?
Computer information systems at Ferris.
Oh, okay. And they subject you to my classes? They know what's up. But just general computer information system, you need to know all this stuff if you're going to be any good at IT. You know, understand certificates and all that kind of stuff. They don't have like a Security Plus requirement, something like that, like Intro to Security, some kind of undergrad in your program.
They did. I took the Intro to Security class here. So I remember when you were talking about certificates and everything in that, but a lot of the material we went through very fast, and I need to take a second pass at it because I understood a lot of it from like a general perspective, but as soon as we got into any specifics about it, then I was just lost.
Gotcha. Yeah, this is the application.
Moved on to a new topic.
This is the application of that. So these are those, like, go back, and I want to say we just finished I taught a section of that, and yeah, it's a lot of material, especially if you're coming at it cold. But like, this is where those certificates, like, the rubber hits the road with that stuff. This is the actual practical application. And I think we make you do this in Microsoft Active Directory in that class, which is like not for the World Wide Web, but if you were setting up an enterprise, it's the same kind of concept. You know, it's all certificates and public and private keys and all that fun stuff, but applied in different places.
Yeah, I did all the labs that were required in the class, but a lot of them I just like followed the instructions and had no idea what was going on.
That's why I try and get people to talk about what they're doing in those labs, because that is my fear. Even people who've taken like a Windows class and an Active Directory class. If you got better ideas about that, I'm all ears.
I don't have any other questions, and I don't want to take up any more of your time.
All right, guys. See you, Isaac.
Well, hey, thanks for letting me sit down and catch that info, Isaac.
Yeah, of course.
Yeah, actually, I'm recording this, so if you don't want me recording your time here, let me stop this.